So as I told you on Thursday, the graph of the rational functions need two things: the excluded value. In order I found the excluded value, this will be the asymptotes. So look at these examples here. The first one, it was when y equals 1 over x. And the second one, for y equals 1 over x minus 3. So here, as you see, this is y equals 1 over x minus 3. So here, the curve are shifted upward with 3 units. So that's mean if you have 1 over x minus c, when c is on the denominator or the number is in the denominator, that's mean the curve or the graph shifted up 3 units. Or you can say here c units. For if x1 over x minus c, that's mean minus c. So this is the number, c will be the number of the shifts. If it is 1 over x minus 2, that's mean the graph will shift it up 2 units. So here now this is for 1 over x. Now for the first function here, what is the vertical asymptotes? At x equal what? What is the vertical? I remembered you. This is the vertical and this is the horizontal. So what is the vertical asymptotes for the first function?
0.
0. Bravo. When x is 0, this is now the vertical asymptotes. And now where's the horizontal asymptotes? At y equal
0.
0. Bravo. Now look at the second function for y equal 1 over x minus 3. Where's the vertical asymptotes?
At 5. 5.
The vertical asymptotes.
At 3. 3 miss 3.
When x is a 3. Bravo, here. Oh, sorry, it is here. And where is the horizontal asymptotes? At y equal
0.
0. Bravo. So this is here how to find the vertical and the horizontal asymptotes from the graph. So 1 over x minus 3, that's mean the graph is translated 3 units up. If it is 1 over x plus 3, that's mean the graph shifted down, shifted to the left 3 units. Now, but sometimes you have the graph as 2 over x minus 6, as an example. For this one here, I told you have to go to the denominator and take the 0 of the denominator. The 0 of the denominator will be the asymptotes. But before making or doing this step, you have to be noticed that there is no common factor between the numerator and the denominator. Why? Look at the numerator here, we have 2. Look at the denominator. Here, we have it as 2x minus 6. So let's take 2 as a common factor. You have it as x minus 3. So 2 cancel 2. So x minus 3 when it is 0. So the asymptotes will be at x equal 3. So I will repeat. I told you that if you want to find how many shifts you will shift up or will translate the graph to the right or to the left according to C. If you have as 1 over x minus 5, that's mean they have 5 shifts to the right. If you have it as 1 over x minus 9, how many shifts will be to the right?
9.
9. If you have it as 1 over 2x minus 6, how many shifts to the right? Now, both of you look at me here. For the first one, we have 1 over 2x minus 6. The first step, don't look at C. No, you have to check first if we have or if we can simplify it with the numerator or no. Since the numerator here is 1, So we cannot simplify it. So I will take here 2x minus 6 equals 0. So 2x equals 6 over 2 over 2. So x equals 3.
Yes, teacher.
This is for the first case here. So you have to check if we can find a common denominator, a common factor, sorry, in the denominator. You have to take it as a, so don't take 6. First check if you can take a common factor or no. Sometimes you can solve it like 2 over 2 times x minus 3. So at x equal 3, you have the asymptotes. So when the numerator and the denominator have no common factors, there's a vertical asymptotes at each excluded value, as we see here. So you have to check if we have a common factor in the denominator or on the numerator. If there's no, this will be the excluded value. Is it clear?
Yes.
Yes, teacher.
Now let's have some examples here.
Yes, teacher, in the second example of 2 over 2x plus 3, I cannot take also 2x plus 3 alone. I mean plus 6. And
Yes, you can
simplify
take it. Yes. You can take it and then take the 0 of it, then it at x equal 3. Okay. Now here, let's start with the first one to find or how to graph the y equal 5 over x plus 2 as a rational function. Let's graph it here now. So we have y equals 5 over x minus 2. So the first step here, we have to find the excluded value. This is the first step if you want to graph the rational function. How? Here we have x minus 2. Where is that? As I told you before, to find the excluded value, you have to find the zeros of the denominator. Where's my denominator? It's x minus 2. What is the 0 of the denominator? That means I make it 0. So x minus 2 will be 0 when x equals 2. So this is now the excluded value. This excluded value will be the vertical asymptote. Now, remember, this is the vertical and this is the horizontal. So the vertical is parallel to the, is cutting the x-axis. So I will say when x equals something. And the horizontal asymptotes cut the y-axis. So for the horizontal, I will say for y equal something. The vertical when x equals something, and the horizontal when y equals something. Why? The vertical, when you draw the vertical line, it's intersect the x-axis. So when I told you where's the vertical asymptotes, you have to tell me at x equal to. Why? Because the vertical asymptotes intersect the x-axis. But the horizontal asymptotes, it's intersect the y-axis. So when we name it, you will tell me it's when y equals something. So here, as we see, x equal to, so vertical x. So if I told you x equal to, this will be the vertical asymptotes. Then after that, after I found the vertical asymptotes, let's now graph it here in the coordinates. So we have it as 1, 2, 3, 4, 5, and 6, negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5, and 6, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Then, so when x equal to, this will be the vertical asymptotes. So here is x2, this will be now the vertical asymptotes. When you draw it, you have to put it like dashed line. Now, where's the horizontal asymptotes? Since here there's nothing tell you about it, you have to say, just say it is when y equals 0. So I find the excluded value. How to find the excluded value? By find the zeros of the denominator. The excluded value will be the asymptotes. Then the second step, you have to plot a table. Just you have to put a values for x and y. But be careful. When you put any points from your mind, don't choose x equal to. This is mean excluded value. Excluded, it's mean you have to put all the points from negative infinity up to positive infinity, all the negative and all the positive number, except x equal to. Now, why x equal to? Because this is my excluded value. Sometimes it could be x equal 3. Sometimes it could be x equals negative 1. So according to the question, you have to exclude the points. So here, put any points from your mind except x equal to. So let's put as an example, negative 1, 0, 1, and 3. I accept 2. After that, you have to find now the y's. When x is negative 1, let's bring our function here. This is my function, y equals 5 over x minus 2. But now I have to evaluate x with negative 1. So it comes as negative 1. So it will be as 5 over negative 3 or negative 5 over 3. So at point negative 1, we have it as negative 5 over 3. Now let's find at x equals 0. You have to do the same steps now, but when x is 0. So here we have to put as 0, so 5 over negative 2, which is negative 5 over 2. Now let's try when x is negative, when x is 1. So we have it 5 over negative 1, which is negative 5. And the last one here, let's try 5 over 3 minus 2, which is 5. So after we find the excluded value, plot the points, then write it as 5 over 3 minus, right. So after you find the excluded value, the asymptotes, plot the tables now. Let's draw. At negative 1, was negative 1, we have it as negative 5 over 3. 5 over 3, it's mean 1.333, so it comes like here. At 0, we have it as negative 5 over 2 or negative 2.5, so it is here. At 1, we have it as negative 5. At 3, we have it as 5. So we need more examples here, more numbers. Let's take number 4. 5 over 4 minus 2, which is 2.5. Let's take 0.5. So as 5 over 5 minus 2, which is 5 over 3. So at point 5, we have it as 5 over 3. So as you see here, let's now plot the numbers like this. So we plot the points, as I told you, except the excluded value. When you draw it now, as you see now, this is the vertical asymptotes. This is my curves didn't intersect the vertical asymptotes and also didn't intersect my horizontal asymptotes. Is it clear?
Yes, miss.
Yes, teacher.
The
Yes,
others,
teacher.
miss, do you have any question?
No, teacher. No, thank you, teacher.
No, thank you, miss.
You are. Now, here, by the way, I draw for 5 over x. Here, I draw another function. Wait a minute, please. Where's my I draw for you for 5 over x minus 2, not x plus 2. That's why here you have, yeah, I like can say I draw another example. Now let's have to draw what is the vertical asymptotes of the graph of h of x equal negative 3 over x minus 6. Then you have to graph the function. Yeah. Now here you have to find the vertical asymptotes of the h of x. Here now, h of x is negative 3 over x minus 6. Now, look at the denominator. Can we have a common factor here?
No,
For
miss.
x minus 6.
No.
Can we? No, exactly. So here, since there's no common factor, so the first step you have to check if there's a common factor. If there's no, take the denominator, find the zeros of the denominator when x equals 6. This will be now the zeros of the denominator. So now the zeros of the denominator will be the excluded value. And the excluded value will be the vertical asymptotes. So here, the zeros of the denominator will be the excluded value, and the excluded value will be the vertical asymptotes. So where's the vertical asymptotes here? Who can tell me?
6.
At 6, exactly. So then now here, you have to plot my points as 1, 2, 3, 4, 5, and 6. Let's move it now here like this in order to So here now at x equals 6, we have our asymptotes. So here let's draw a dashed line here. This is for x equals 6. So what does it mean? That means my curve will be here or here. Oh, sorry, here and here, or it could be here or here. As I told you before, it could be first on third quadrant or on second or fourth quadrant. Now, who tell me where the curve will be? My table. If my table with the points on first and third quadrant, here it will be. If my curve is on point in give me the tables and second or fourth quadrant, the curves will be at this quadrant here. So after we find the asymptotes, let's now plot, or let's plot the tables. Now, this is x and this is y. Now, who can give me the numbers here that I can plot x for them?
1, teacher.
1.
0.
Let's try from negative
5.
Let's take negative numbers, please. As negative 2, negative 1. Continue, please. Can we take 0?
Yes, miss.
Yes. Can we take 2?
Yes.
Can we take 4?
Yes. Yes.
Can we take 6?
No.
No, bravo, because this is my excluded value. And let's take 8. Then after that here, let's now find y. To find y, we have come back and use my function. Negative 3 over negative 2 minus 6, which is negative 3 over negative 8. I will evaluate x with negative 2 here. This x will be exchangeable. So it will be as negative 3 over negative 8. You can cancel them. So it will be like 3 over 8. The second one here, negative 3 over. Now let's evaluate with negative 1. So it comes like negative 3 over negative 7 or 3 over 7, since you can cancel them.
One more question.
Yes, Huda.
Here you are adding them negative 1 with negative 6, right? Not multiplying.
Yes.
Okay, thank you.
Yeah, welcome. So here we have h of x equals negative 3 over x minus 6. Now here, instead of x, you have to evaluate it now with 0. So negative 3 over 0 minus 6.
Negative 6.
Negative 6.
Negative 6.
Then minus,
half.
cancel minus. Divide by 3 is 1. Divide by 2, by 3 is 2. So we have it as 1.102. Now let's try at point 2. So what we have to do here, just you have to bring 2 and evaluate it here. So we have it now as negative 3 over 2 minus 6.
Negative 4.
Negative 4.
And it will be 4.
So then
Negative
minus,
4.
cancel minus, so it will be 3 over 4. Then h of x equals negative 3 over x minus 6. But now you have to evaluate with 4. So let's cancel x. Let's take 4. Let's bring this 4 here. So we have it now as negative 3 over 4 minus 6.
Negative 2.
Negative 2. Bravo.
Negative 2.
So here we have it as minus, cancel minus. We have it as 3 over 2. And then the last one, h of x equals negative 3 over 8 minus 6. So we have it as negative 3 over 2. So we found the excluded value. The excluded value will be the asymptotes. We plot then the points. Now let's plot the points on the chart. Yeah. At point negative 2, we have it as 3 over 8. Now 3 over 8, if you simplify it, you will find, or if you divide it in your mind, you will find that it's less than 0.5. So at point negative 2, here we have, sorry. At point negative 2, it have to be here. Sorry, here. There's negative 2. Then at point negative 1, you have it as, I'm sorry, I make a mistake.
Miss, it's positive.
Oh, yes.
Yes.
Sorry. So at negative 2, we have it as here. At point negative 1, we have it as 3 over 7. So it will be greater or at 0, we have it as half. By the way, both of 3 over 8 and 3 over 7 is less than half. So I don't know how we grow something like this, something like this.
Miss, maybe it will be in the quadrant 2 and 4.
Yes, that's what
But teacher 6, yes, 6 is greater than k. I mean, yes, it's greater than 0.
Wait a minute, please. Now at point 2, we have it as 3 over 4, which is 0.75. At point 4, we have it as 1.5. At point 8, so the curve will be like this. This is after we plot the points. Now for the second one here, we have it as 0.8. At 0.8, we have a negative 3.2. So we need another points. Let's take 0.9 as, or yes, 0.9. Do you know why I choose 0.9 now? After we graph my function here, we have only 1 point. So I need another points to tell me where's my graph. So I take another point like 0.9. So I have it lies as negative 3 over 9 minus 6, which is negative 1. So at 0.9, we have it as negative 1. So after I have 2 points now, I can decide now, like it's supposed to be like this. So I will repeat. Here we found the excluded value. The excluded value will be what? Will be my vertical asymptotes. Got it?
Miss, but 6 was greater than 0. Why teacher it was in the 4th quadrant and in the 2nd quadrant?
6 is greater than 0.
No, teacher, we said that if we want to know that our graph is in which quadrant, 2 quadrants,
Yeah.
we will see if it is greater than 0 or not.
Let's look. Yeah. And you will check if it is on first or third quadrant. Look at K. Where's K? It is K over X. So look at K. If K is greater than 0, this will be in the quadrant 1 and 3. And if K is less than 0, will be in quadrant 2 and 4. So here, where is k? It's -3. K is in the numerator.
Yes, okay.
So since k now is a negative, sorry, so it has to be in 2 and the second and in the fourth quadrant.
Okay.
Okay, so
Okay.
Farah now remind us of new things here. From the function, if you look at it as -3 over x minus 6, from x minus 6, we have to find our asymptotes. And from the points of -3, since it is negative, since it is less than 0, so that tell me my curve must be on the second and on the fourth quadrant. That's what we say. So from the function, we can guess that my curves will be on the second and the fourth quadrant, and my asymptotes at x equals 6. If I know these informations, just I need to plot many points to graph my curve. Is it clear, grade 8?
Yes, miss.
Yes, miss.
Yes, miss.
So let's summarize what did we say yesterday. What would say today. Here you have to look at the function. The function to find, I need to draw it. So I need to find the asymptotes. To find the vertical asymptotes, you have to find the excluded value. To find the excluded value, we have to find the zeros of the denominator. After that, we put my asymptotes at x equals something. Then we look at k. If it is k is -3, or it is negative, so it has to be on the second and in the fourth quadrant. If it is positive, it's supposed to be in the first and the third quadrant. In this case, only if you have it k as a constant. Next time, we'll find it as x -3 over x minus 6 as an example. So here there's no k. So it cannot tell me about it. So here now, after that, we plot a points. These points tell me where's my curve. Be careful. When you choose your points, don't take 0.6. This will be an excluded value. When you draw it here, this is my vertical asymptotes. From here, it has to be on the second and in the fourth quadrant. So here, then we need 2 points, many points, sorry, to graph my function. Do you have any questions? Oh, yes.
When we want to graph the vertical function, I will not make a mirror because it might be different.
No, you have to make a mirror here. Let's look at here because you have as point z2, you have as a 3/4. Ah, yes, you cannot make a mirror, yes. So you need to plot a points here and the second and in the fourth quadrant. In other words, when you plot the points, which you know that the asymptote is at point x equals 6, just take a points less than x, less than 6, and the points that's greater than 6. That can help you. When you plot the points, take points less than 6 and greater than 6. Because for sure, the graph will be approaches to 6. Okay, inshallah, tomorrow when we take more examples, you will understand more. Now, we have here 2 minutes left. Let's talk about the horizontal asymptotes. The horizontal asymptotes here. Sorry. How to know the horizontal asymptotes? Here we have it as 1/x And here we have it as 1 over x plus 3. So you have to add 3 to the rational, to 1 over x. In the previous one, we have it as 1 over x plus 3. The 3 was added to the denominator. But here, no, the 3 was added to the whole function, to the 1 over x. In this case here, that's mean you have to shift or to translate the functions 3 units up or 3 units down. If you had,
Teacher,
yes,
I'm sorry for interrupting you, but teacher, the period finished before 3 minutes ago.
okay, thank you so much.
Thank you so much.
Okay, bye-bye.